My presentation will be today in 5 steps. First, we will see the objective of the research, why we make it. Then I will make an introduction of reverse engineering, Taguchi method, and technique of order preference by study to the solution as small boxes, because they are the main topic that I have used in this research. Then we will see the procedure. We have 3 steps. The first step was to make a kind of decorative antenna reverse engineering, and then to make the application of rapid prototyping to fabricate a pattern. This one was the first pattern that we made with the rapid prototyping, and then the mobile inside analysis. And then I will introduce the result and the introduction of the research. First step was the selection of the factor and the orthogonal array model. And then the main effect analyze decide the optimal parameter. And in the end, we summarize the conclusion and the reference I have made for my research. The objective for this research, the first one was to create CAD data from existing report to design the new model. Because in the beginning, we were having this part in the small one, and we don't have the CAD file. Okay, so the first objective was to create the CAD file of this original part. And the second objective was to determine the best plastic injection process parameter that will minimize the shrinkage and the warpage. The introduction. Reverse engineering is the process to create CAD model from a physical part or prototype. In the conventional product development cycle, the initial conception design of the surface is often described by stylists who formalize their idea by making cake or wood model. Reverse engineering is also defined. Reverse engineering is also defined as a process of obtaining geometric CAD model from 3D points by scanning an existing real part. In a simple way, reverse engineering has been found that the people, if they have some idea, they make like wood or samples first to see how it's good. And then they need to get the CAD part that they can make the mass production. So that's why you can say, like, if we have the existing wood part, like in our case this one, we make the scan. Then we have different points of the part, and then we use the CAD software. In our case, is UG to mesh the construction, and then we make the surface, and then we get the CAD model of the object that we have in the beginning. Taguchi method is a powerful tool to design of high-quality system. It introduces an integrated approach that is simple and it aims to find the best range of design for quality, performance, and competition cost. So Taguchi method, the Taguchi technique have 3 stages: system design, tolerance design, and parameter design. And this last one I have used in this research, because the parameter design is used to obtain the optimum level of process parameter for developing the quality characteristic and to determine the product parameter value. So in this research, parameter design is complete to achieve the optimal level of process parameter, leading to minimize warpage and volumetric shrinkage during the manufacturing of decorative antenna. Access. In definition for combinatorial function by similar to ideal solution and proposed by Kant and John in 1981. The ideal solution is called positive ideal solution. It is a solution that maximizes the benefit criteria attribute and minimize the cost criteria attribute, where the negative solution, also called a anti-ideal solution, maximize the cost criteria attribute and minimize the benefit criteria attribute. In our case, the criteria attribute we have is warpage and volumetric shrinkage. And that's what we want, that we want to minimize the warpage and the volumetric shrinkage during the manufacturing of our product. To make the process, there is 6 steps we have to follow. First, when we get the decision matrix, we have to calculate the normalized decision matrix using this formula, where in this case we have X, it's the warpage and the shrinkage. And we make a matrix, and then we calculate the normalized decision matrix, where I and M and G are how many factors we have and how many tests we have made. The next step of process is to calculate the way normalized decision matrix. And to do that, because our idea calculated before, so we need to calculate the assessment criteria, the rate assessment criteria. And we use this formula to calculate. What we